Can you believe it's been a whole year since JWST launched on December 25th, 2021? To celebrate, let's take a look back at everything it's done in those 365 days. From the complicated unfolding of the telescope in space, to arriving in the right orbit, 1.5 million kilometers from Earth, to calibrating and commissioning the mirrors and instruments, and finally giving us some absolutely spectacular images. At the end of the video, we'll even touch on some of the problems JWST has experienced too, and what's next for the telescope. It all started on Christmas Day 2021, when an Ariane 5 rocket launched JWST from French Guiana. The 6.5 meter primary mirror of JWST, along with its huge sunshield, are too big to fit inside any rocket, so it had to be folded up delicately before it was stowed away in the hold. Once the rocket had safely delivered the telescope into space, it began its month-long journey towards Lagrange Point 2, the point in space that JWST orbits. L2, as it's called, is a point a million miles further from the Sun than Earth. JWST was sent to this point because it means that the telescope's sunshield will block light and heat from the Sun, Earth, and Moon all at the same time. It's especially important to block heat from these objects because JWST is an infrared telescope, and hot things give out infrared light. This means that to make sure JWST is as good as possible at seeing faint, distant objects, we need to block as much light as possible from everything else. This also means that JWST can only point in certain directions, and specifically can't point at the Sun, Earth, or Moon, or anywhere near these things, as they're so bright that they would damage the incredibly sensitive detectors on board the telescope. During its journey to L2, the complicated unfolding of the telescope and the sunshield took place. Despite this process having 344 separate single points of failure, this process went perfectly, and by January 10th, 2022, just over 2 weeks after launch, we were left with a fully functioning and perfectly positioned telescope. In fact, the Ariane 5 rocket placed JWST into its orbit so perfectly that the telescope used hardly any extra fuel to get into position. And this extra fuel is enough to extend the life of the mission from 5 years to 20 years. So we have a lot of science to look forward to. Once in orbit and fully unfolded, it was time to calibrate and commission the telescope. This involved making sure that all of the mirror segments were aligned perfectly to focus the light onto the secondary mirror. For example, this is an image of a single star, but it's repeated 18 times, one for each mirror segment, because the mirrors aren't yet working well together. The mirrors were then aligned so that all of those images sat on top of each other, eventually leaving us with a single mirror, working perfectly and ready to produce beautifully crisp images. To demonstrate how well this went, JWST took a couple of selfies. The first one shown here, before much calibration had taken place in February. You can see one segment is brightly lit and the rest are sat in relative darkness, while in this updated one, all of the segments are evenly lit and calibrated to work as one. We also saw this image, the first one where we see a single star as a single star, telling us the mirrors are aligned, and the first of the detectors is also calibrated and working too. It also shows off the diffraction spike pattern we'll be seeing in JWST images for years. 6 big ones and 2 little ones. These come from the hexagonal shape of the mirror and the struts that hold the secondary mirror in place. And I have a video going into all of the details of that, linked in the description and in the top corner right now. Throughout the rest of March and April, the other instruments inside the telescope, that's the cameras and spectrographs that split up light into its component wavelengths, were also calibrated and cooled down to their operating temperatures. There are 4 different instruments on board: a near-infrared camera called NIRCam, a mid-infrared camera and spectrograph called MIRI, and these first 2 instruments are the ones that create most of the actual images we see. The other 2 instruments are the near-infrared spectrograph called NIRSpec, and the fine guidance sensor that helps us point the thing in the right direction, but also hosts another near-infrared spectrograph too, called NIRIS. This one works slightly differently to NIRSpec, but I'm afraid the details of exactly how will just have to wait for another video. And if you want to know the details of what spectra actually are and how they teach us about planets and stars, then please check out the video I made all about this topic. I think it's a really cool one. The instruments were all cooled down to different temperatures, depending on the wavelength of light they detect. And this reduces noise, as any heat can provide infrared radiation that can spoil the images, and we certainly don't want that. The coldest instrument on board is MIRI, and it operates at just 7 Kelvin. That's 7 degrees Celsius above absolute zero. We saw a few more final calibration images by the end of April, demonstrating that every instrument on board was online and ready for science. That's exactly what happened next too. Science began. The telescope started taking images and spectra, preparing to change the way we see the universe forever. July 12th, 2022 was the magic day. The first images from JWST were released. Here, I want to go through pretty much every image we've seen from JWST. I won't go super into the details of each one here, but I have separate videos about pretty much every one of these images if you do want those details. I have a playlist that I'll link in the description that contains all of those videos, plus loads more JWST content. So feel free to look through that and learn more about your favorite images right there. Here though, let's start on July 12th and see those first images. Well, technically one actually got sneakily given to us the day before, but I'll not be the one to complain about that. At the time, this was the deepest image ever taken of our universe. Although I suspect more recent JWST data has taken that crown since. It shows an enormous cluster of galaxies called SMAX 0723 in the center. And that is so massive that it's warping the light of the more distant galaxies behind it, causing them to appear warped and distorted. We get long arcs, and some even appear multiple times due to the gravitational lensing of the cluster. When July 12th rolled around for real, our eyes got a real treat. First of all, let's look at the Carina Nebula. This is an enormous nebula that's a huge cloud of gas and space dust. It lives in our Milky Way galaxy, and it's the perfect place for forming new stars, so it's full of hot young stars, and it's absolutely stunning. This is a near-infrared light image, and we also saw a mid-infrared image too, which is slightly lower energy light that is better at piercing dusty regions and letting us see deeper into the structures. Next up, we got to see Stephan's Quintet, a group of 5 galaxies, 4 of which are interacting with each other and even merging. Although this one here is actually way closer to us and isn't getting involved in any of that at all. I really like this image because, in a sense, it gives us a snapshot of all of cosmic history. In the background, as in most JWST images, we can see incredibly distant background galaxies that are some of the earliest to ever form. We then have the most recent, but still quite distant main galaxies in the image. And then we have these foreground stars too, which are in our own galaxy and just happen to be in the way of the image. So we see a little bit of everything here. Again, we saw a mid-infrared image too, and this reveals an incredibly bright center to one of those galaxies, indicating there's a supermassive and super active black hole here. And as it consumes vast quantities of matter, it's causing the area around it to glow incredibly brightly, outshining everything else in the image. We then saw this. Not an image per se, but the very first spectrum of an exoplanet, a world around a star other than our sun. By splitting the light it receives into its component wavelengths, like an infrared rainbow, JWST can see what elements and molecules make up the atmospheres of exoplanets. This takes a lot of analysis to do well, but after initial work we saw water, presumably in vapor form, in the atmosphere of this planet. It's not a stunning image, but it's still a stunning discovery. The final image from day one of releases was this, the Southern Ring Nebula. A different kind of nebula than the Carina one. This is a shell of gas and dust around the remnants of a dying star. This one is incredibly beautiful, and again we saw it in both near-infrared light here and mid-infrared light here. In fact, much later in the year, we actually got an updated view of the nebula too. It's a couple of composite images that look pretty different to the original ones, but equally beautiful. If all this wasn't enough for you, just a couple of days later, we got a sneak peek at Jupiter from JWST. This was actually calibration data used to make sure JWST could track moving objects well enough. And it turns out it definitely can. The resolution is so good, even from this short exposure, that we can see Jupiter's atmospheres and its rings too. Yeah, Jupiter has rings. Want to see them even better? Well, you can, because on August 22nd, we got an updated shot of the gas giant, and it is incredible. Look at the rings, the infrared auroras, the weather, and the great spot too. Absolute chef's kiss from me. We're getting ahead of ourselves though, because plenty of images were released between those two Jupiter shots. Lots of JWST data goes public as soon as it's taken. So if you know what you're doing, you can go online and make your own images, even before those objects get official releases from the teams involved. For example, by July 19th, we were seeing images like this one of the Phantom Galaxy, taken by JWST and processed by amateurs online, but still stunning to look at. Here, I'm going to stick to the officially revealed images for now, but there are a couple of videos on my channel that go through more of those unofficial images. At the end of July, we saw a whole bunch of incredibly distant galaxies, some competing for the title of the most distant ones we've ever seen, and are threatening to change the way we think about galaxy formation. These results are still preliminary and need confirming, but aren't a bad thing at all. They just mean we might need to tweak some models a little bit. For example, because we're now seeing smaller galaxies at greater distances. This isn't a shock though, because this telescope has the best resolution of any infrared space telescope, so it's refining fuzzy blobs into unfuzzy objects, which are naturally smaller than the fuzz they create. After this, we got to see another stunning galaxy, but this one is a bit closer and is the result of a galaxy collision millions of years ago. It's called the Cartwheel Galaxy. We got a few shots of it, as is tradition, but I think this near-infrared one is my favourite. But the combined one is great as well. Near the end of August, we got an update of the big spiky Calibration star we saw earlier, now in full colour and with even more detail, especially in the background galaxies we can see. There was a glorious landscape of galaxies from the Sears team too, and some super cool close-ups came with that, including one that looks like Pac-Man, one that looks like a Kraken, and this big one that's just plain gorgeous. On the timeline, it was then the Jupiter image that we've talked about already, before a really surprising image of this, a star with what looks like rings around it. These rings aren't some weird artifact of the telescope or anything like that. They're actually real. This star is actually a pair of stars, and the type of stars they are and the way they interact periodically blows off a load of matter from one of those stars. It repeats on a really steady timescale, and hence we end up with cool-looking ringed stars. As September rolled around, there was a lot of planets on the menu. The month started with some exoplanet data. We got the very first direct image of an exoplanet from JWST. Admittedly, it does just look like a fuzzy blob, but when you think about how small it is and how far away it is, it's incredible that we can see anything at all. We also saw another exoplanet spectrum, this time from a planet called WASP 39b. And it showed a huge amount of carbon dioxide in its atmosphere. And this is the first exoplanet we've confirmed the presence of CO2 on. In a brief interlude to planet season, the next image that JWST gave us was the glorious Tarantula Nebula. This is an absolutely stunning nebula, similar to the Carina Nebula, and was actually considered as an option for one of the first JWST images to be released. But in the end, the Carina Nebula was chosen over the Tarantula. At least we got to see it eventually. Next, it was back to planets, starting with an image and a spectrum of Mars, quickly followed by a stunning view of Neptune and its moons. This also gave us an incredible shot of the rings around Neptune, and this up here is actually Neptune's moon Triton. This is a really weird moon, and if you want to learn why it's so much brighter than the planet itself, you'll just have to check out my full video on the image. September ended with another beautiful shot of a spiral galaxy. This one's called IC 5332, and as we head into October, the treats don't stop. JWST began spooky season by checking in on the aftermath of the DART mission. This was the spacecraft that deliberately smashed itself into an asteroid to change its course. And JWST captured the huge plume of debris that was ejected from that impact. The next thing we saw was a quartet of re-released images that had the JWST data combined with X-ray data from the Chandra Space Telescope, giving us more detail in the images and some stunning colors to match. From here, we saw a pair of galactic friends, a spiral galaxy and an elliptical galaxy, pretty much holding hands. Next up, we saw one of the most spectacular images yet. This is the Pillars of Creation, another beautiful star-forming nebula. And once again, we saw it in both near-infrared and mid-infrared. So let me know which one of those you think is better. Or tell me if you prefer this image that combines both of them together. As October continued, we were given an image of some incredible galaxies in the very early universe that formed around a quasar. That's a supermassive black hole, causing the matter around it to glow very brightly. We also saw another pair of galaxies that are plunging deep into a merger, as well as another cluster of galaxies called MAX 0647, performing some epic gravitational lensing. This brings us to November, which began with a view deep inside a dwarf galaxy that's close enough for us to see individual stars within it. And then we rolled back the years and imaged a star that's still forming. It's inside a gorgeous hourglass-shaped cloud and has yet to burst into life as a full-fledged star. This protostar was quickly followed by a neat view of Arbel 2744, showing off an incredible landscape of galactic bodies and highlighting some of the earliest galaxies yet seen by humanity. November ended with a few spectra of the exoplanet WASP-39b that we mentioned earlier, and these are now the most detailed we've ever seen, and showed us the surprising presence of sulfur dioxide in the atmosphere, which tells us that photochemistry is happening on this planet, something we've never seen beyond Earth before. November then ended with a final view of a beautiful pair of merging galaxies. December began with a view of Saturn's largest moon, Titan, which is the second largest moon in the solar system. It showed us the lower atmosphere and the surface too, using NIRCam, and even teamed up with the Keck telescopes in Hawaii to see clouds moving across the moon. After this moon, which is relatively nearby to Earth, we went to the other extreme and got some really exciting data that confirmed we have definitely seen some of the earliest galaxies to have formed in the universe. We saw hints of this earlier in the year, but we needed more follow-up data to confirm these distances, and that's exactly what we saw here. We got confirmation that we have seen galaxies that formed as early as 300 to 400 million years after the Big Bang, which is incredibly early compared to the 14 billion or so years old that the universe is now. This was followed by a medium deep image that showed us an incredible landscape of galaxies, and again shows off the power of JWST to image incredibly distant galaxies in incredible detail. At the point I'm recording this is the latest official image release we've had, but what a list it's already been. Of course, I've had to record this slightly before the actual day of the 1-year anniversary, so there is the chance something is released between then and now. If that happens, I'll do my best to make a separate video covering that, and then I'll leave a comment below to let you all know that's happened, if it does happen. Despite all of this awesomeness, it hasn't exactly all been plain sailing for JWST since the launch. There are two main issues that it's had to deal with since it unfolded and started taking images. The first is the pesky problem of micrometeoroids. These are tiny grains of space dust, traveling incredibly fast, that can smash into JWST's big ol' mirror. We know it's been hit at least 14 times already, and that number is probably actually even larger by now. But the biggest issue with them is that one of them was way bigger and way more energetic than we expected. The powers that be convened a team of experts to come up with a plan after this big impact. And the plan now is to basically, whenever possible, avoid pointing the telescope in the directions that are most likely to have these micrometeoroids. The other notable problem has been with one of the observing modes of the mid-infrared detector MIRI. As I've said, the telescope has 4 instruments, but each of these can be run in a few different modes, giving 17 observing modes in total. One of those modes on MIRI started feeling extra friction and forces when it was turning one of the wheels it uses to filter different wavelengths of light into the detector. Extra unwanted friction is bad and can damage the insides of the instrument. So this mode was immediately stopped being used until they could figure out what was causing the problem. 2 months later, and without really explaining what changed, NASA told us that they have figured out a safe way to use the mode, and it is being used once again. This is good news, as all modes are now safe to use to explore the universe. Let's just hope that whatever the problem was doesn't come back or get any worse. Now that these couple of problems seem to have been mitigated, let's end this 1-year anniversary celebration by getting excited about what we know the telescope is observing soon, or even things it has observed recently and we can expect to see the images of very soon. I'll list a few of the ones I'm most excited about, but please let me know if you have a favourite that I failed to mention here. The obvious ones for me are the remaining planets in our solar system. That's Saturn and your favourite planet, Uranus, whose window of time when JWST can see it actually opened on December 23rd, 2022. Uranus will be awesome to see, especially since we've had a taster with the Neptune image. Uranus and its rings are twice the size of Neptune, and the planet is closer to us, so those images should be really awesome. Saturn will be visible to JWST in the early part of 2023, and some other interesting moons in the solar system have already been observed too. This includes Jupiter's moon Callisto, and excitingly Saturn's moon Enceladus, where JWST is even hoping to image plumes of water near the poles of the moon, although it will need some luck to see them. Other exciting targets include a lot of people's favourite exoplanet system, TRAPPIST-1. This is a system of 7 planets orbiting a small star, and 3 of them could have liquid water on them, so seeing spectra from these planets will be incredibly exciting. Other than planets, Pluto and its companion Charon have been imaged already too, as has Sedna and quite a few other solar system bodies. Further afield, there are so many exciting galaxies and nebulae that I won't name them all, but revisiting a lot of the gorgeous things Hubble has seen will be very exciting. Famous things like Andromeda, the Sombrero Galaxy, and even the Hubble Deep Field patch of sky. All of these will be so awesome when they come. Of course, maybe the most exciting things that we'll see with JWST are the unknown things that we'll see by accident or haven't predicted yet. Those could be the most exciting. This has been quite the journey. I do hope you've enjoyed the video and the year we've had with this awesome telescope. If you enjoyed this, I'd love it if you considered subscribing to the channel, as we have loads of spacey content already up there and lots more planned to come very soon too. Please think about sharing this video with any space-loving friends you have too, as we've put in loads of work for it and would love to share these images with as many people as possible. Leave a comment too to let me know your highlight of JWST's first year. I hope to see you in another video very soon. Until next time, stay safe team. I'll see you soon. Bye!